All right, welcome. If you work in the geospatial world, you know we are absolutely swimming in data. I mean, we have more high-res satellite and drone imagery than we've ever had before. But the big question is, how do we make sense of it all? Today, we're going to break down how deep learning is completely rewriting the rulebook for GIS and remote sensing.
So, here's the game plan. We're going to start with why the old ways just aren't cutting it anymore. Then we'll get into the deep learning revolution that's changing everything. We'll look under the hood to see how it works, check out its real-world impact, and this is the important part. Talk about the tools you can actually use today. And finally, we'll peek at what's just over the horizon.
Okay, so let's start with the big problem. We are facing a serious data challenge. The sheer amount and honestly, the complexity of modern geospatial data, from multispectral to hyperspectral imagery, it's just overwhelming our old methods of working.
And let's be real for a second. The methods a lot of us learned and have trusted for years, they just can't keep up. They were good for their time for sure, but in this new era of big data, the cracks are really starting to show.
So what exactly are we talking about? Well, for one, manual interpretation is just so slow, and it's so easy to make mistakes. Then there's the reliance on so-called handcrafted features. This is where an expert, a person, has to manually tell the computer what to look for. It's not just tedious, it's impossible to scale up when you're looking at massive, complex datasets. It just completely bogs down. But this is where the story takes a really exciting turn. Because we're facing these challenges, a whole new way of thinking has come along, a true paradigm shift. And that, of course, is deep learning. So what is it really? Well, think of deep learning as a way to teach computers to see and recognize patterns, kind of like we do, but at a scale that's just impossible for a human. It uses these complex neural networks to automatically learn what's important straight from the raw pixels of an image. You don't have to tell it what to look for, it figures it out. And this really shows the fundamental difference. The old way, on the left, that was all us, doing all the heavy lifting. But the new way, on the right, the model itself learns the important features. It starts with simple things, like edges, and builds up to complex shapes, like buildings or roads. That's the core shift right there. We're moving from manual labor to automated insight. Now, I know this can sound a bit like magic, but I promise, it's a very structured process. So let's pull back the curtain for a second and see how a typical deep learning project in GIS actually gets done. It really boils down to a clear 5-step workflow. First, you've got data collection, getting your imagery from satellites, drones, whatever. Then comes pre-processing, which is just a fancy way of saying you clean up the data. You georeference it, normalize it, so the model can make sense of it. The real heart of it is model training. This is where we feed it labeled examples, basically showing it this is a building, this is a road, over and over again. Then you run inference. That's when you let your trained model loose on new data. And finally, you visualize the results in your GIS software to make some real decisions. Okay, the theory is cool and all, but what does this actually mean for the real world? This is where the power of deep learning becomes, well, pretty undeniable. The proof, as they say, is in the pixels. We are seeing this tech make a huge difference in so many critical areas. For urban planners, it means automatically mapping every single building in a city. For environmental scientists, it's about tracking deforestation in near real time. And in disaster response, and this is incredible, it means getting a rapid damage assessment to first responders, finding collapsed buildings and blocked roads in minutes, not days. And you know what? The results just speak for themselves. This comparison shows a standard, kind of out-of-the-box model versus one that's been optimized. The jump in performance is just massive. It's not just one metric either. This pattern holds up across the board, in accuracy, precision, all of it. The optimized models are just consistently, significantly better. Let's just focus on that accuracy number for a second. 92.3%. That is a huge jump from the baseline. Getting that level of accuracy automatically and at scale, that's what makes this a truly transformative technology for our field. Okay, so you might be thinking, this is really cool, but it sounds like something for PhDs in a research lab. But here's the best part. That's not true anymore. This power is moving out of the lab and directly onto your desktop. In fact, if you're a GIS professional or a student right now, there's a really good chance you already have access to all of this. These deep learning capabilities are being built directly into the industry standard software you're already familiar with, like ArcGIS Pro. You can use tools right now to automatically find things like swimming pools or solar panels. You can classify what those objects are. You can do pixel-level classification to create a land cover map. And it's not even just for 2D imagery. You can classify 3D point clouds. This is not theory anymore. This is a practical toolkit that's ready for your next project.
So we've seen where we are, which is pretty amazing. But where are we going? The speed of innovation here is just incredible, and the future of geospatial analysis is being built as we speak. We're moving towards something called explainable AI, or XAI. It's going to help us understand why a model made a decision, which is huge for building trust. We're also seeing real-time analysis on devices like drones, so a drone could literally be analyzing imagery as it's flying. And we're pushing deeper into 3D analysis, building these incredibly smart digital twins of our world. So the main takeaway is this: the technology isn't some distant dream anymore. It's here, it's powerful, and it's already in the tools you probably use every day. The models are getting better and the applications are exploding. So really, the only question left is, what problems are you going to solve with it? What are you going to discover?